Good morning. My name is Riza, and I will be presenting the study titled Introducing New Capacity Planning Metrics in Production Planning. The study was conducted by myself along with my advisor, Dr. Farouk Hamza, and Mr. Samir Indanat from Ghafari Associates. So planning is an essential step in managing production flow on a project. If the proper time and resources are adequately allocated to planning efforts, the probability of success of the project will increase. But although planning is very crucial at early stages of the project, ongoing planning during production, which includes capacity planning, is instrumental in shaping the production and thus worth studying. But what is capacity planning? It is the assignment of the activities, the load, to the available labor, equipment, and resources, the available capacity. In the context of this study, the load is the number of activities that you commit to complete, while the capacity is the number of tasks executed by the end of the week. Thus, it is important to study the balance problem between load and capacity. Allocating adequate time and resources to planning is only one solution to the problem, but it cannot contribute to the success of the project if there is a mismatch problem between capacity and load. So a lot of research has gone into the area. A lot of research has been done in this area, where topics such as project planning, task planning, variability, buffers, limited resource allocation, and matching load to capacity have been explored. However, capacity planning has not been discussed at the weekly work plan level within the context of the last planner system. This is what the study tries to address. Planners cannot manage what they cannot measure. Furthermore, measurement cannot happen without having the proper metrics. Thus, the need for metrics to understand the inside workings of capacity planning arises. We realize that there are not enough metrics. We realize that there are not enough metrics. We realize that there are not enough metrics in the field of planning that aid in adequately describing the state of capacity planning on a certain project. Accordingly, 7 primary metrics and 4 secondary metrics were devised that will serve as tools to diagnose the pathologies and assess the performance of capacity planning. Note that the metrics discussed in this study are to be used for measurement on a weekly basis when applying the last planner system. So the first metric is the capacity to load ratio in man hours. It is calculated by dividing the quantity of man hours it took to complete the activities that have been executed this week by the quantity of man hours required to complete the activities committed to the weekly work plan. But since nobody calculates at the weekly work plan level the planned and actual man hours, we are calculating the CLR man hours with the surrogate metric, which is the CLR, the capacity to load ratio. This metric is a comparison between the chosen load with the actual capacity. It is calculated by dividing the total number of activities executed this week by the number of activities on the weekly work plan. Note that in this study we are measuring the allocation of resources through the number of tasks. The third metric is called the required capacity ratio, which is the RCR. It represents the fraction of completed activities that are critical. The fourth metric is called the required percent complete, RPC, which represents the percentage of critical activities that have been completed. So it is calculated by dividing the number of executed activities that are critical by the total number of critical activities. The fifth metric is the RPC man hours, which is the same as the RPC, except that RPC is at the level of activities, while RPC man hours is at the level of man hours. It is calculated by dividing the quantity of man hours that we expend to complete the critical activities, divided by the number of man hours required to complete the total critical activities. The sixth and seventh metric are complementary and related. The weekly deviation, WD, gives us an indication of how far the team has deviated from the weekly work plan and the direction of the deviation. And the weekly deviation ratio is the normalized weekly deviation divided by the weekly work plan. A set of secondary metrics were also created to help in the analysis. The first secondary metric is the GLUT, which is a representation of the percentage of completed activities that are not critical. So this means that the non-critical activities are being executed before critical ones. And the second secondary metric is the starvation, which is the percentage of critical activities that have not been executed. This means that the critical activities are starving for resources. Thus, a misallocation factor can be deduced as being the sum between glut and starvation. This sum is the waste in capacity planning. And the fourth secondary metric is called the normalized team deviation, is the average of the weekly deviations in absolute. So in other words, it is the weekly deviation per week. We used the case study approach to analyze these metrics. We took two projects, two ongoing projects in the US. The projects span over 100 weeks. The vPlanner software was used, and the teams on each project are highly functioning and interdisciplinary teams that meet on a weekly basis. Since I'm short on time, I will only discuss the findings of 3 teams from project 1. So if we consider team 3, the PPC, if PPC is the only metric we're using to measure performance, then team 3 is performing very well. But since there are large deviations in NTD and CLR, then team 3 is not matching the load to the available capacity. Furthermore, the fact that there is high glut and starvation per week indicates that team 3 is also misallocating the available resources. On the other hand, team 7 has the second highest PPC, but seems to be performing averagely on all other fronts. This is an indication that team 7 is able to mostly execute whatever it is committing to complete each week, but may not be paying much attention to matching the load to the capacity or properly allocating its resources. If we look at team 9, although this team has the lowest deviation and the closest CLR to 1, it is still misallocating its resources since it is starving 45.3% of its critical activities and wasting 84.5% of the resource availability. Moreover, team 9 also has the second lowest PPC. Therefore, looking at the metrics related to matching the capacity to the load is not enough. Teams should also monitor the allocation of the available resources. A fine comparison of the two projects was made, and as can be seen, it turned out that Project 1 outperformed Project 2 on all fronts. In conclusion, people are not aware that there is a mismatch problem. This study showed the existence of the mismatch problem. One cannot rely on PPC alone to assess performance. Teams focus on one aspect of performance only. This study also showed that there is a lack of capacity planning metrics. Teams do not learn from previous mistakes, and no metric is a standalone metric. Teams are setting wrong priority rules in resource allocation. And finally, the metrics do show the presence of capacity planning problems. Finally, if planners use these contributed metrics and place them in a dashboard system to monitor them continuously and regularly, they will most probably be able to make their capacity planning journey smoother.